here and see if it will start recording, and then that way you can have two videos to watch if this works. I don't know if it will because this thing has been going crazy these days. So the first thing we're going to do is question 41. This is a typical kind of problem that you would see. They want to know what the sine of negative 8 pi over 3 is. This is problem 41. So here's what you should know. You only need to know the first quadrant of the unit circle right here. Pi over 3 is right there. That ordered pair there is 1/2 root 3 over 2 for cosine pi over 3, sine pi over 3, and tangent of pi over 3 is root 3. I know the answer here is root 3 over 2. The question is it positive or negative? Now, most kids are just messed up on this stuff because they don't pay attention when I do this stuff, so they get irritated. But I would point out to you that you should know because it's over 3, it's a 60-degree angle. Once you've done that, Mr. Carroll showed you, you can take 3 into negative 8, or 3 just into 8. 3 goes into 8 twice. 3 times 2 is 6. If you subtract, you get 2. That means when you take 8 pi over 3, it goes negative 2 pi around the circle, and then you have a remainder of 2 all over 3, so it's 2 pi over 3. That's your remainder. Now, Mr. Carroll showed you how to rotate on a circle, hopefully. Negative angles are clockwise. So right here, you're going this way. That's negative 2 pi. What I told you before, though, there's the even side of the circle. This is the even side right here. This is the odd side over here. So right away, I would just tell you, all you need to know is the remainder. If we know this is an even number, we know this is on this side of the circle right here. Then you have to rotate 2 pi over 3 in the clockwise direction because it's negative. That's negative pi over 3. Negative 2 pi over 3 is right here, so the answer is negative root 3 over 2. And that's how you do those problems. Any questions on that? Beautiful. Then we're going to go off and do number 47. Now please note, stop me if you have a question. Don't just sit there. If you don't know what you're doing, find out. 47 says sine of t equals 4/5. This is another kind of problem you should know how to do. This is pretty straightforward stuff. This says A, sine of pi minus t, and B, sine of t plus pi. And all they're asking you to do here is find the values. So what I do when I do a problem like this is I go, oh, where would I be if I had an angle? So what I would do is this first. Is I would draw my little circle here. And I would say, this is 0 over here, and this is pi over here. And then it says, we're going to go in a rotation negative t, I believe. See that? That says negative t. That means you're going this way on the circle. So here's pi. If you go negative t, you're up here. So you have the phrase, all students take calculus. The sign's positive there, so it's 4/5. That's how I do that problem. So you have to know on a circle that where's pi? It's over here. You have to know the rotation is negative. So that means you're going clockwise. So if I'm over here, I'm going this way. That means all students take calculus. I'm in this quadrant right here. Part B is done the same way. If I draw a circle. I find pi on the circle. This time it says rotate t. See, that's positive t right there. So you're rotating this way, you're coming down this way, you're in this quadrant. All students take tangents positive, cosine's positive there, but we want in this quadrant right here, tangents positive, so that means it's negative 4 over 5. And you're done. How's that? Wasn't that sweet? Are there any questions else on this section?
For number 41,
Yes.
I don't see how you get from, like, sine of negative 8 pi over 3 to negative root 3 over 2.
How did I get to negative root 3 over 2? Well, here.
Yeah.
Again, when you do these kind of problems, all you need to know is what pi over 3 is, because of the denominator. I know it's a sine is the y value on the unit circle. It's root 3 over 2.
Oh, okay.
Okay, so all I'm doing now is I'm going to take 3 goes into 8 how many times? It goes twice. I got 2 times 3 to be 6. I subtract, I get 2. So I know since it's negative 2 pi. Then I have a remainder of 2 pi over 3 left over. So I'm on the even side of the circle here, and I'm rotating in the negative direction. So I'm going, there's negative pi over 3 there. This is negative 2 pi over 3 here. And I know the phrase all students take calculus. I know the answer is root 3 over 2, so I know it's got to be negative. So that's what I'm doing there. It's just knowing where you are on the circle. Does anybody else have a question there? Okay, then I got a little activity for you before we start, because you guys are supposed to know what you're doing. This is in, oh, here you go. Let me do something with you real quick. Each one of you know I gave you these packets here. I want to point out to you that what we're going to be doing today is we're going to be doing all of these values right here, 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 Pythagorean identities, and cofunction identities. We've already talked about even and odd functions, so all of this stuff we've done right here. We've done the unit circle over here, and just so you know, this circle right here is a unit circle. It's 30, 45, 60, and 90. This is the first quadrant right here. Remember I gave you the phrase, all students take calculus. That's how you know the values of the trig functions. You should note that the tangents aren't here, but we can put them on real quick. We know that 1/2 divided by root 3 over 2 is root 3 over 3. That's the tangent, y over x. Root 2 divided by root 2 over 2 divided by root 2 over 2 is 1. Root 3 over 2 divided by 1/2 is root 3. We know that 0 over 1 here is 0. We know that 1 over 0 here is undefined. With that, you know the whole unit circle, because they're all the same values. Pi 6's are all 30-degree angles. Pi 4's are 45-degree angles. Pi 3's are 60-degree angles. Those are your values. Pi 2's, those are the values as well on the unit circle. So if you come over here, we know that's pi. This is 0 for tangent. This is root 3 over 3 for tangent, but it says all students, so the tangent's negative. We know it's 1 here, that's negative. And we know it's negative root 3 there. So the tangent of 2 pi over 3 is negative root 3. Tangent 3 pi over 4 is negative 1. Tangent 5 pi over 6 is negative root 3 over 3. Note I got all students take. Tangent's positive in this quadrant. We know that it's root 3 over 3 for 7 pi over 6, tangent. Tangent of 5 pi over 4 is 1. Tangent of 4 pi over 3 is root 3. See how that works? Anything time you see tangent with a pi over 2, it's always undefined. In the fourth quadrant, the cosine's positive. The tangent's negative again, so at 11 pi over 6, the tangent's negative root 3 over 3. 7 pi over 4, the tangent's negative 1. And the tangent here, and 5 pi over 3 is negative root 3. So there's your unit circle. We've done this. We're going to be doing the rest of these today. And that's why I gave you that sheet, so you could do all your work. Now, I want you to take a few minutes. This shouldn't take you more than about 5 to do this whole thing. I'll give you about 5 minutes, and you can do this worksheet here. Now, if you can't see it, just tell me to move it when you get down to it. Real quick, you can do these like in seconds. So this is the kind of stuff you need to know how to do really quickly. Now, some of you want to memorize the unit circle, and I would caution you and warn you not to do that. And basically, if you know the first quadrant there, you know all the answers. If you know how to rotate on a circle. Isn't this fun? I'll keep my mouth shut for a second or two. See if I can put this thing down here. There you go, you can see them all now. As you're doing that, I would tell you, typically I would give this to you in class and give you a quiz on it, and I'd give you about 5 minutes to do the whole thing. Because that's how fast you can do this stuff if you're doing the work. Got them all done, Carson? Not saying anything?
Yeah, I'm trying to do them on a different piece of paper because I was not able to print them because my printer's been broken. So I'm trying to do them on a different piece of paper.
That's all right. Anybody done yet? You should all know the answer to number 10 because I just did it with you with the sign. Now, I'll give you a little hint because of you people that are not good, you're working very fast there. If you take pi over 6, we know that the ordered pair is root 3 over 2, 1/2. We take pi over 4, we know the ordered pair is root 2 over 2, root 2 over 2, and 1. If we take pi over 3, we know the ordered pair is 1/2 root 3 over 2. If we take pi over 2, we know it's 0, 1, and undefined. And if we take 0, we know it's 1, 0, and 0. That's cosine, sine, and tangent. So without doing any work, and I'm just going to be a little frank with you because I got to move a little bit here. See these pi over 6s here? I know the sine is 1/2. I know the tangent, which I didn't write up here, is root 3 over 3. The cotangent's the reciprocal of root 3 over 3, and this is root 3 right here. So you should note that if you do the reciprocal of root 3 over 3, you rationalize it, it's 3 root 3 over 3, which is root 3. That's how quick you can sort of do this stuff. Now you just have to know rotation on a circle. And I write my phrase, all students take calculus. If I go 5 pi over 6 in the negative direction, we're rotating over here. I know it's right there. The sign is negative there. That's how fast you can do that. You draw a circle over here. You write the phrase, all students take calculus. You're doing 11 pi over 6 negative. That's almost all the way around the circle this way. You're right there. It's pi over 6. They're coterminal angles, by the way, pi over 6 and negative 11 pi over 6. We note all trig functions are positive there, so it's done. Pi over 3, we know the answer is root 3. We have to know where 8 pi over 3 is. 3 goes into 8 twice. That's 6. 2 left over. So it's 2 pi and then 2 pi over 3. So if you learned about the circle, the even side of the circle is right here. 2 pi over 3 is the remainder. There's pi over 3 there. 2 pi over 3 is there. All students, the tangent's negative. We know pi over 4. Pi over 4, the reciprocal of the cosecant is sine. We know that's root 2 over 2. It's 2 over root 2. If you rationalize, you get 2 root 2 over 2. The 2's cancel. This is either positive or negative. I don't know what it is yet until I draw it. My circle. Right there, all students take calculus. I want to rotate in the negative direction, 3 pi over 4. That's negative 1 pi over 4, 2 pi over 4, 3 pi over 4 is right there. The tangent's positive, so that sine, cosine are negative. The reciprocals are also negative. See how fast I can do this stuff if I know my circle? Now we got pi over 3 here, cosine. The cosine pi over 3 is right there. It's a half. X is cosine. Question is it positive or negative? 3 goes into 17 how many times? 5. 5 times 3 is 15. Subtract, I get 2. So I know it's 5 pi and then 2 pi over 3. If I draw a circle, all students take calculus. This is the even side of the circle. This is the odd side of the circle. 5 pi is over here. Now we just got to rotate 2 pi over 3. Since it's positive, we're rotating this way. So we're going to go 2 pi over 3. Here's pi over 3 down here. 2 pi over 3 is right there. The cosine's positive a half there. Anything that's over 2 with a tangent, which I have up here, right here for you, is always undefined. I don't have to do any work there. I already know it's undefined. Because pi over 2, we know the ordered pair there is 0, 1, or 0, negative 1. Negative 1 over 0, or 1 over 0 is undefined. Pi over 6, that's a cosine function. Cosine of pi over 6 is root 3 over 2 right there. So we know the reciprocal is secant, so it's 2 over root 3, because we know the reciprocal. Then we rationalize it. We get 2 root 3 over 3. So I know the answer here is 2 root 3 over 3. The question is it positive or negative? So I have to draw it again. I write the phrase right here, all students take calculus. Then I divide 6 into 17. That goes twice. That's 12. Subtract, I get 5. So it's 2 pi, and then 5 pi over 6. The even side of the circle is right there, so I have to rotate 5 pi over 6. 5 pi over 6 is right there. That's 150 degrees if you didn't know that. And I'm right there, so all students, that's a cosine function, it's negative. The tangent of pi over 6 we know is root 3 over 3. Again, we have to know where we are on the circle. We have to do 6 into 35. That goes 5 times. That's 30. Left remainder is 5. That's 5 pi and then 5 pi over 6. You draw your circle again. All students take calculus. This is the even side of the circle. This is the odd. 5 is odd. Then we got to go 5 pi over 6. We're right there. That's negative root 3 over 3. Cosecant of 15 pi over 4. Well, we already did the cosecant function above here. We have pi over 4 is root 2. We already know it's root 2 because the reciprocal of root 2 over 2 is root 2. So we have to just decide if this is positive or negative. So we have to divide it out. 4 into 15 goes 3 times. That's 12. Left over with 3. So it's 3 pi with a remainder of 3 pi over 4. If I draw my circle again, all students take calculus. This is the odd side of the circle over here. This is the even side. We're at 3 pi. Oh, right here is 3 pi, then we got to go 3 pi over 4. Pi 4, 2 pi, 3 pi over 4 is right there. This is negative because the reciprocal of cosecant is sine. And then we did this one, and part of your homework, somebody asked this, I think it's 41. 3 goes into 8 twice, that's 6. Subtract, you get 2. Since it's negative 2 pi. And then you have a remainder of 2 pi over 3. You draw your circle. This is the even side of the circle. We want to go negative 2 pi over 3, so we're going to go down this way. That's negative pi over 3 right there. Negative 2 pi over 3 right there. All students take calculus. This is going to be negative 1/2. and you're done. So some of you will take an hour and a half to do that, but if you don't know the circle, that's what it takes, because you have to learn the circle and how it works. That's why many of you will write down a whole circle and memorize it. That is not what you do. So what you're doing in Precalc is you're learning how to rotate quickly. Is there any questions on that? Now typically I'd give you a quiz on that, but I'm not going to do that. So and you would do it yourself. Some people would go, "Oh yes, I got it. I'm so good." And I'd say, "Yes, congratulations." So we're going to go to the notes now, section 4.3. If I can find my paper now. I moved everything. Shoot. Let's see, what did I do with it? Oh, jeez. It's always fun doing all this stuff because I got all these papers every which way. This is 5th hour. Okay, we got 5th hour notes. That beautiful circle I did for you guys. Oh, yes. This says right triangle trigonometry. Okay? So, if you read your book, they go into a lot of different ideas, and this is basically right triangle trig. It says right here, 1 second look at trigonometric functions is from a right triangle perspective. Consider a right triangle with an acute angle labeled theta. Relative to the angle theta, the three sides of the triangle are hypotenuse, the opposite side, and the adjacent side. In relationship to theta, adjacent is next to hypotenuse, is the longest side, it's across from the right angle, and the opposite side of the angle there. With these lengths of the three sides, you can form the trig ratio, sine, the reciprocal cosecant, cosine, the reciprocal secant, tangent, the reciprocal cotangent. When they say it's 0 to 90, it lies in the first quadrant, so they're all positive. So let's do our little note section right here. First thing I'm going to do is draw a right triangle. I'd make a little box there. Across from my box is my hypotenuse. I'm going to call my angle here theta. Across from theta is the opposite side. Next to the angle is called the adjacent side. With that, I can label my 6 trig functions. I got the sine of theta, the cosine of theta, the tangent of theta. The reciprocal of the sine is the cosecant of theta. The reciprocal of cosine is the secant of theta. And the reciprocal of tangent is cotangent of theta. I write them across from each other because they're reciprocals. Now, if you were in Algebra 2, they should have taught you this acronym, SO, GA, DOA. What does that stand for? The sine is the opposite side right here over the hypotenuse, OH. So you write opposite over hypotenuse. The cosine, ca, adjacent hypotenuse over hypotenuse, I should say. And the tangent, toa, opposite adjacent. Now, we don't have to memorize this, except you should note the sine is reciprocal is cosecant. This is hypotenuse over opposite side. The secant is hypotenuse over adjacent side. And the cotangent is the adjacent over the opposite side. And that's how you define your 6 trig functions. Next, our cofunctions of complementary angles are equal. So, what you need to know when you look at a triangle, see that's a 90-degree angle. This is theta here. This angle up here is 90 minus theta. And that's how they come up with these cofunction identities, or complementary angles, showing you they're equal. Therefore, theta is acute. The following relationships are true. The sine of 90 minus theta is the same thing as the cosine of theta. The tangent of 90 minus theta is the same thing as the cotangent of theta. And the secant of 90 minus theta is the same as the cosecant. The cosine of 90 minus theta equals the sine. So those two are related right there. The cotangent of 90 minus theta is the tangent. And the cosecant of 90 minus theta is the secant. You should note this also works for radian measure. 90 is the same thing as pi over 2. So when you look at your worksheet here, they're just showing you these are cofunction identities. They use pi over 2 instead of 90. In Precalc, you'll be seeing basically radian measure. Any questions so far? We're going to talk about reciprocal identities. You'll have to know these. The sine of theta. The reciprocal is the cosecant, so it's 1 over cosecant of theta. The cosine of theta, that's cos theta. The reciprocal is the secant, so you can write it as 1 over secant of theta. The tangent of theta, the reciprocal is cotangent, so you can write it as 1 over cotangent of theta. The cosecant of theta, its reciprocal is sine, so you can write it as 1 over sine theta. The secant of theta, the reciprocal is 1 over, the reciprocal is cosine, so you can write it as 1 over cosine theta. The cotangent theta, the reciprocal is tangent, so you can write it as 1 over tangent of theta. Those are called reciprocal identities. We also have quotient identities. That's for the tangent, by definition, is sine of theta over cosine of theta. Cotangent of theta, its reciprocal is cosine over sine. So it's cosine theta over sine theta. And last but least, we have what we call Pythagorean identities. The Pythagorean identities, in your book, they don't write them all out the way that most kids don't pay attention. So what you need to note here is the following. Pythagorean means there's something squared, a squared plus b squared equals c squared, or x squared plus y squared equals r squared, x being cosine, y being sine. So you can write sine squared theta plus cosine squared theta. And since it's a unit circle, that's y squared plus x squared is 1. That's what they're talking about. Cosines x sines y. You also have 1 plus tan squared theta equals secant squared theta. And 1 plus cotan squared theta equals cosecant squared theta. Now, I tell this to kids every year, you can transform these identities. On your paper here, when you look for Pythagorean identities, they only give you the one versions. You can manipulate those identities, so I'll write them out for you so you can see them. You can solve this for sine squared theta. You can set it equal to 1 minus cosine squared theta. You can also solve it for cosine squared theta. So it'll be 1 minus sine squared theta. That's how you manipulate an identity. You take this next one, 1 plus tan squared equals secant squared. You can solve it for tan squared. That's secant squared theta minus 1. And then you can solve, I always like it to equal positive 1. So if I bring the tangent squared over and set it equal to 1, I can write secant squared theta plus tan squared theta equal to 1. All I did was bring the tan squared over there. Now it's positive, so it's secant squared. Oops, that should be minus. Almost did a boo-boo there. That's a minus. I better fix that. Minus tan squared theta. If you bring it over, it's negative. Same thing goes with the next identities. You have cotan squared theta here. You can solve it for it, so it's cotan squared theta equals cosecant squared theta minus 1. And again, if you take cosecant squared theta, bring the cotangent over here, you get minus cotan squared theta equals 1. So we can write this as cosecant squared theta minus cotan squared theta equal to 1. Those are the versions most folks forget. Now, if everybody's caught up, we can do the examples. Are you ready? Some are you nodding, some are saying nothing. I love the voices. They make me rejoice. It says, find the values of 6 trig functions. Hopefully these don't go away. Oh, that's you. You guys are good. So what you're going to do here is you're going to write sine theta, cosine theta, tan theta. The reciprocal of the sine is cosecant theta. The reciprocal of cosine is secant theta. And the reciprocal of tangent is cotangent theta. If I look at my triangle here, I have a missing side. Right there. That's a leg. That's another leg. Across from the right box is a right triangle. That's the hypotenuse. When kids are going to do the Pythagorean theorem here, I say you should not do that. If you want to save time in math, you have to know, if you take the hypotenuse, which is 4, and you square it, minus one of the legs, 2, and square it, you can find the missing side quickly. That's 16 minus 4, which is 12, and we take the square root. Square root of 12 is root 4, root 3, which is 2 root 3. The missing side, since the triangle is always positive, is just 2 root 3. You don't have to worry about the Pythagorean theorem. That's the quick way to do this stuff. once you've done that, you're finding the angle theta here. Using this angle theta here, we can say the sine is opposite 2 over hypotenuse 4, which is a half. The cosine is 2 root 3 over 4. Adjacent, 2 root 3, hypotenuse 4. You can simplify that to root 3 over 2. The tangent is the opposite 2 over the adjacent 2 root 3. The 2's will cancel. You'll get 1 over root 3. Before I rationalize that, I would say, oh, the cotangent's root 3 over 1, so it's root 3. And if I rationalize root 3, I get root 3 over 3. The reciprocal of sine is 2 over 1, or 2. That's the cosecant. The cosine's reciprocal is 2 over root 3. And you have to rationalize that, root 3. So it's 2 root 3 over 3. Once you know how to do right triangle trigonometry turns out to be pretty simplistic. But again, you got to stay practicing with this stuff. So don't just sit there and, think you can do it. You have to practice it. If I turn the page, can I turn the page? Folks, I got a thumbs. Yeah, I'm just making sure. I don't want to be yelled at. Okay, we're going over to the next examples on the back side. Here they gave you a decimal. Most kids have a hard time with decimals. Cosine of theta is 0.4. How do I do the sine and the tangent? Well, I always tell them to take the decimal, 0.4, and change it to a fraction. 0.4 is 4 over 10. If I take a 2 out, I get 2/5. Then I can draw a little graph like so. I can draw a right triangle like so in the first quadrant. I note that it said the cosine there. It's the adjacent side, which is 2. The hypotenuse is 5. I have to find the leg. Right there. Across from the right triangle is the hypotenuse. So if I take 5 and square it and subtract the 2 squared, that's 25 minus 4, which is 21, and take the square root. The missing leg is root 21. So that's how I do that. I call my angle right here theta. I want the sine opposite hypotenuse, root 21 over 5. I want the tangent opposite adjacent, root 21 over 2. And you're done. Look at problem number 3. It says, let beta be an acute angle such that tan beta is 4. Find the values of the cotangent and the secant. They want you to use trig identities. So that's what they're going to ask you to do. But you don't have to do anything with the A. It just says find the cotangent. What's the cotangent of beta? Anybody tell me? I'm waiting.
1/4.
Ah, beautiful. She knows the tangents are what? A reciprocal of the cotangent. So if we know the tangent, which is right here, is 4, the reciprocal of 4 is 1/4. And now you have to use an identity to find the secant. There's actually a couple of ways you could do this. You could draw a triangle, which I will do later, but before I do that, I'm going to do a trig identity. So what I'm going to do is I'm going to look and say, which one can I use? I see a secant squared is tan squared plus 1. I know the tangent, so I know the tangent squared. So what I'm going to do is write secant squared beta equals 1 plus tan squared beta. Now they use a u there. You can use a beta, a theta, whatever you want to use. I like theta the best, but they use lots of different ones. Secant squared beta equals 1 plus 4. Tan is 4. And you're squaring it. Secant squared beta equals 1 plus 16. Secant squared beta equals 17. Take square root. Take square root. The secant of beta equals plus minus root 17. Question is, what's the answer, positive or negative? Well, if you read right here, an acute angle right there means it's in the first quadrant. So the secant of beta is root 17. We could have also done that another way, because we know the tangent of beta is 4 over 1. If it's acute, it's in the first quadrant. We know right here we got y, that's 4, x is 1, 1 squared plus 4 squared, that's root 17. We know the cosine, and I'd write beta here, we're using beta, is adjacent 1 over root 17, hypotenuse, which I rationalize, and I get root 17 all over 17. So there are a couple of ways you can do that. But if it says use a trig identity, that means use a trig identity. See how that works? Isn't this stuff sweet? We're going to use trig functions to prove the following. What you want to do when you do a proof is you start with the more complex side and you make it equal to the easy side. So what I tell students to do is draw a line. This is the easy side, so you cannot cross that red line. That's a boundary, don't cross it. So no touch this side. You have to make the more difficult side the easier side. That means you have to use your trig functions or your trig identities to do this. So we can take the sine and leave it alone. That's sine x is a headache. The secant of x here, right here, is 1 over cosine x. That's over 1. You can write that as sine x over cosine x, which is by definition a quotient identity, which gives you the tangent x. That side equals that side, it's proved. next problem, again, I'm going to draw my line, my boundary line. No touch. Some kids will just go to the paper and tell me it's the cosecant squared. No, you have to prove it. So you have to change the cotangent there. So if you look at your paper, see the cotangent there? Cosine over sine. Well, the cotangent squared x is the same thing as sine squared x over cosine squared x. If it's cosine or cotangent cubed, it'd be sine cubed over cosine cubed. If it was to the fourth, it'd be the cotangent to the fourth x would be sine to the fourth x over cosine to the fourth x. So this works continuously with different exponential powers. First thing I'm going to do is write 1 plus cosine squared x over sine squared x. Now we're doing adding fractions. We need a common denominator. 1 in sine squared is just sine squared. You ask yourself, what do you multiply this 1 here by to get sine squared? You have to multiply it by sine squared. Sine squared times 1 is sine squared. There's a plus sign. Sine squared goes into sine squared. What do you multiply sine squared to get sine squared? 1. 1 times cosine squared is cosine squared x. That's a Pythagorean identity right there. Cosine squared plus sine squared. If you look at your paper here, and you have to know these, sine squared plus cosine squared is what? The loneliest number, 1. That's 1 over sine squared. You go back to your trig identities. 1 over sine is cosecant. 1 over sine squared is cosecant squared. That's how those work. So this is just cosecant squared x, which is right there. And it's proved. Isn't this fun? That's what you're going to be doing. They get really complex, so you have to learn this stuff. And then we have 2 more to go, and we're done for today. Not unless you have more questions. It says a 12-meter flagpole casts a shadow. Find beta, the angle of elevation to the sun. Well, a lot of kids get confused on these problems, and I just say draw a right triangle. Up here in the sky is the sun. He's happy. Hey. He's casting a shadow. I got a flagpole here, right there. The flagpole's 12 meters. It cast a shadow. It's on the ground, you know. That's 12 meters. Find B, the angle of elevation. Beta is the angle of elevation to the sun. Reading my triangle, that's the hypotenuse, so that's opposite, adjacent. Opposite, adjacent. What trig function is that? Yep, you're right. Tangent. Tangent of beta is opposite over adjacent. That's 12 meters over 12 meters. That's tan beta is 1. What angle gets you 1? That's tangent. Can somebody tell me?
Would it be 45 degrees?
Yeah, it's 45 degrees. So if you take your calculator, if you didn't know that, you turn it on, you push clear. Make sure it's in degrees. See, it says degrees, radians, gradients. Well, we want degrees, so I hit enter. It says degrees. Second function. That means the inverse of the tangent at 1. Close your parenthesis, hit enter, you get 45. Which is the answer. 45 is the same thing as pi over 4. You know that. That's a radian answer. So if you wanted to see what happened in radians, you hit degrees, flip it over to radians, hit enter. Now it says inverse. You do second tan again. Second tan 1. Close parenthesis. It doesn't give you pi over 4. It gives you what? 0.785398, blah, 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 blah. But if we show you second pi, push clear, second pi, divided by 4, see the answer? That's pi over 4. 0.785398, blah, blah, blah. But we'd use pi over 4. So I showed you how to use the calculator now. And our last problem for today deals with another trig function, finding the angle. It says a ramp is 17.5 feet in length. Well, obviously, here's the ramp labeled for you. It rises to a loading platform that's 3.5 feet off the ground, right there. Find the angle beta. They want you to find this angle beta. The ramp makes with the ground. You have to read, this is a right triangle. That's opposite. That's hypotenuse. What trig function is that?
Sine.
So you go sine of beta equals 3.5 all over 17.5. And you're going to use your calculator. Push clear. Now you see I changed it to radians, so I'm not going to get the answer, so I have to put it back to degrees. Degrees. Seconds. Sine. It's in parentheses, 3.5 divided by 17.5, close parenthesis, hit enter. And you get roughly 11.5 degrees. That's an approximate answer. And there you have it. Are there any questions today? Well, that's the last lesson I'm really going to do for this quarter with you before the quiz, which is tomorrow. Remember, it's 16 problems. It can be done rather quickly. If it takes you a long time, I don't know what to tell you, except you got to work harder. Each problem's, you know, a couple points apiece, and you're done. And that's the quarter. Your notebooks are due today. Some of you have already turned them in. Some of you have not. You need to get them in. And if you don't have any questions about anything, you can